pause the video, have a go at this question, and then we'll have a look at it together. So we want to find the size of angle y, which is this angle here. Now it's not a right angle triangle, so we can't use trig, but we can use sine rule. The reason why we can use sine rule is because we have opposite angle and side, and we have opposite angle and side. So we'll label these angles and sides. So angle y, I'm just going to label as angle A. So opposite angle A will be side A. If we label this angle B, opposite angle B will be side B. If we also write out sine rule, which you are given on your formula sheet, so we've got sine A over side A is equal to sine B over side B, and that would also be equal to sine of angle C over side C, but we don't have any of those, so we can just ignore that one for now. So we stick in any values that we do know into our equation, so we'll rewrite it over here. So sine of angle A, well that's sine of y, so sine y divided by side A, which is 10, is equal to sine of angle B, which is 64, so sine 64 divided by side B, which is 15. Okay. To get sine y on its own, if it's divided by 10, that's just times 10 to both sides. So we'll have sine y, because the times by 10 cancels out the divide by 10, is equal to sine 64 over 15 times by 10. I always run out of room on any question that I do. So sine y is equal to, we type all that on our right hand side into the calculator. So that's sine 64 divided by 15 times by 10 gives us 0.59919, so on. We keep that number in our calculator. To find angle y, well, to get rid of sine, we need to do inverse sine. So it'll be sine to the power minus 1, 0.5991, so on. This number that we had here. So we do inverse sine, stick that answer in, and that will be 36.8123, so on, degrees. It doesn't ask us to round, but I'm just going to do it to one decimal place. So that'll be 36.8 degrees. Now for the second one, so instead of finding an angle, we want to find a length, so a side. So we want to calculate the length of AB, which is this side here. So we'll label that as X. Now using the sine rule again, if we look at side X here, this angle here will be opposite side X, and we also have another pair of opposites because we have this side and we have this angle. Now we can actually work out what this angle is because we have the other two angles, and we know that angles in a triangle sum to 180. So to find this angle here, we start with 180 and we take away these two angles, it will tell us what we've got left. So take away 96, take away 31 is, take 96, take 31. This angle is 53. So again, I'm going to write out my sine rule, but this time because I'm finding the side, I'm going to put my sides on the numerator and my angles on the denominator. It just makes the rearranging a bit easier. So we have A over sine A is equal to B over sine B, which is also equal to C over sine C. Now because we have angle C and side C, and we have angle A and side A, we can just ignore this middle bit here and just use these two. So which is the one that we're looking for? We're looking for side C. So C is what we want to find, so we'll call that X, divided by sine C, which is 53. So sine 53 is equal to A over sine A. Now side A is 8.4, divided by sine of angle A, so that's sine 31. Now to get X on its own, if it's divided by sine 53, we want to times both sides by sine 53 to get rid of that denominator. So these will cancel out, and that will leave us with X is equal to 8.4 over sine 31 times by the sine 53, which is, we type all that in, so 8.4 over sine 31 times by sine 53 gives us 13.0253 and so on. Again, it doesn't ask us to round, but I'll just do it to one decimal place. So that will be 13.0 centimetres as our final answer.